talk about percents. So I guess one of the most obvious kind of things that happens with percents, one that's talked about the most, are either your test scores or usually we're dealing with a pie chart. So like 100% would be the whole pizza. And if we talk about half percent or half of it, we have 50% of the pizza still left over. We could talk about a quarter of the pizza, okay? And you can go on from there. But percents are always dealing with like absolution of 100%, all right? So when they talk about that, 100%, that would be one whole pizza. And if we only had half a pizza, then we would talk about 50% of it, so 0.5. And then if we talk about a quarter of the pizza, that would be 0.25. So how do these things work? Well, what's happening with our percentages is whatever the percent is, it's getting divided by 100. And what happens here is we have one whole item. If we do 50 divided by 100, then that's where we get 5 over 10, and then 1 over 2, which is 0.5 or 0.50. So when we look at these percentages, they're always out of 100. Now, that doesn't mean you have to divide by 100 every time and simplify it and do all that, but understanding that it comes from a concept of 100% will hopefully make some of this a little bit easier to understand. So what we have right now is 81.0%. And what happens when we do a percentage to the decimal, we are going to take this and we are going to move it 2 places to the left. So we're going to take this and jump at 1 spot and then 2 spots and then move the decimal there so that it becomes a 0.81. Now, that's all well and good when there's 2 digits. However, when we look at the next problem, you can see it's only 1 digit. So what happens when we skip that second spot and put the decimal here? Well, that second spot gets filled in with a 0 so that we actually get to be 0.06, and that would be 6%. And you can always revert these back. So when we divided them by 100, we can also times them by 100 to get back to the percentage, which moves the decimal 2 places to the right as opposed to the left. So then this one would turn back into 81. This one would turn back into 6. And the last one would turn back into 5.3. But let's take that 5.3 and move it 2 spots to the left. Once again, we create this empty spot where we're going to put a 0, but this one is actually 3 decimal places long because it already had a decimal place to start with. And if we times it by 100, we would move the decimal 2 places to the right, and we would come back to 5.3. So when we're converting, whether it's a percentage to a decimal or a decimal to a percentage, let's talk about that. Percentage to a decimal, we want to go 2 spaces, and we're going to go left. If we want to go a decimal to, oops, sorry, I'm just looking at my other screen and I see my picture's about to cover that up. If we want to do decimal to percent, that's when we want to go 2 spaces right. And we could also talk about timesing it by 100, and then this one would be dividing by 100. So once again, when we convert one way to the other, there's always the inverse operation to get back to what we want. So we're either going to multiply or divide by 100. We can move it 2 spots to the left or 2 spots to the right. So you can convert both ways. Okay. Next question. We are going to look at sales tax. Now, we did a little bit of this the other day, but let's go back to it again. find 4% sales tax on $15.20. So an item that's $15.20. So first off, what we want to do is we want to take that 4% and convert it to a decimal. So we're going to do that 4 decimal again, move it 2 spots, put the new decimal there, and then put a 0 in the empty spot, so it'll be 0.04. So we are going to take this object, whatever it is, that is $15.20, and we're going to times it by 0.04. So if your Taco Bell items came up to $15.20 and there's a 4% sales tax associated with it, we would then multiply these together, and then we would tack that on to the 15.20 to find out what our whole thing would be costing us. So in this case, I don't want to do the long process of multiplying this out. However, I will show you how it does work. So there are 1, 2, 3, 4 numbers behind the decimals. Now you could move this 2 spots this way, 2 spots that way, and turn 1520 times it by 4, and we would do 0, 8, 0, carry the 2, because 4 times 0 is 0, 4 times 2 is 8. 4 times 5 is 20, so we would carry the 2 and put the 0 down here. Then 4 times 1 is 4, 5, 6, and we would do that and get 6080. So my guess is, how many times did we move it? 1, 2, 3, 4. We would move this back 1, 2, 3, 4 spots. And the tax for this item would be roughly 61 cents. Now, never claim to know it all the way. So we have 15, what was it? 1520. 1520. And we're going to times it by 0.04. And if you look, 0.608. So that's 61 cents. So we did do it correctly, okay? But I always want to double check. And I want to make sure I remember my basic steps too. But we moved that decimal 1, 2, 3, 4 times because we did it 2 on the top and 2 on the bottom. So that means we have to do all 4 of them at the very end. So whenever you're multiplying decimals, that's how I like to practice it. But if you learned a different process, however your process was taught to you, by all means, yeah, do whatever works for you, okay? So let's go on to this one. There is a 30% markup. All right, so now we're going to take this item and we're going to mark it up by 30%. So let's take our 30%. Let's convert it to a decimal. So we're going to move it 2 spots to the left, so that would be 0.3. And we'll take this $150 item and times it by a 0.3. Well, if that's the case, we can take the 150, we're going to move it 1 decimal, so we're only going to move it 1 decimal when we're finished with this whole thing. But we should have 0, 3 times 0 is 0, 3 times 5, 15, put the 5 down here, carry the 1, 3 times 1 is 3, plus 1 gives me 4, and remember, we have to have 1 decimal, so it's 45. So this new item that was $150 that we are marking up by $45 actually becomes a grand total of $195 after markup. Okay? And even looking at the last step for the last problem, we would take 1520, add the sales tax, add that 0.61, and then when we add these, just line them up and add them straight down. So if there was something to carry, you would carry it to the next column. 1 plus 0 is just 1, 6 and 2 make 8, then a 5 and a 1, and we have our new price with the sales tax, or with tax. I guess it does say sales tax in the problem. It would be $15.81. Okay, so those are our 2 markups, or you could even do a discount. If there was a 30% mark down on it, we would subtract $45 instead of adding the $45 to it. So just make sure you read and finish the problem too. Just because you found when you multiply those numbers together and got 45, what is that? Well, that's the markup addition to the original cost. So don't stop there. Keep on keeping on. All right. So once again, we're going to do some more 35% off an item and find a discount. So now we're going to take our percentages away from what the item cost. So we have a 35%. Sorry, I didn't pick my pen yet. 35%. Remember, we want to convert it to a decimal. So it's 0.35. And then we would do 56 times 0.35. So we'll move it. You could move this 2 spots. But just treat it like the decimal's not even there. Ignore the decimal until you are all done, then count however many numbers are behind the decimal and make sure you move it that many spots. But from what I'm visually seeing, I don't even want to focus on it. I do want to try a different game though. Let's try and do the box method and see how this works. I want to see if this works. And this is me playing games. I put the tens place in the first column, and then put the ones place in this column. And then I put the tens place in this column, put the ones place in this column. So when I multiply these together, I should get 30. I'm going to multiply these together to get 18. This is going to give me 25, and this is going to give me 15. So how this should work, when I do this with like terms, add the diagonals. So we would have 1, 5. We're going to do 18 and 25, so that's 30, 43. So 4, 3, and then 3, 0. Let's try that. 0, 6, 9, 1. And if I did this correctly, we would knock off 1960. Now, your brain's probably going, what did he just do? Well, I don't know if I did anything right. So let's double check first. And then if it's right, let me explain my thought process. 2016. Oh, what did I mess up? So would it have been? How did I get? I got off by just 1. So where did I go wrong? So that is 13. Carry the 1. 2 and 2 make 4. That's right. 6 times 5 is 30. And then 15. Interesting. I don't know. I'll have to play with that one. But let's backtrack to this. So let me show you, and remember, I'm trying to adapt like Common Core math to what I have learned. What I have learned is we do 5 times 6 to get 30. Then we do 5 times 5 to get 25, plus 3 more, 26, 27, 28. Then we move on to the next number, but that's in the tens place, so we have to have a placeholder. And now we're going to do 3 times 6, which is 18, carry the 1. And then 3 times 5 is 15, plus 1 is 16. So when we do that, we get 0 here. We get 8 and 8 is 16. And I still get 1960. Did I type something in wrong? 56. Oh, I did 36, not 35. 6 times 0.35. Ah, dang. Okay, so I did do it right. All right. Okay, all right. But do we notice everything has a placeholder? Like there's the ones place, there's the tens, there's a ones place here, there's a tens place and a tens place. So when you make this box, you're almost creating the different ones, tens, and ones. And what happens when we multiply a tens times a tens? Don't we get it in the hundreds? So that's why I was doing like the 1 5 here, then the 4. I don't even remember what it was. Let's redo this. So 5 6. And then 3 5. So this was 15, this was 18, this was 25, and this was 30. So when we do this, this was like a tens times a tens. We want to look at the hundreds place, where this was a tens times 1. So we're actually looking, and tens times ones, this is where we're looking at kind of the tens columns, which is why we put 43 here, and then we go to the ones because 5 times 6, but the ones would be here. So we have ones, tens, hundreds. Let's see if I can highlight that. So we have ones, we have tens, and we have hundreds. And that's how it starts to get portrayed in this box method. Now, sometimes this box method isn't the nicest, but once you start doing this, oh man, the box method is about as helpful as all get out. And we'll talk about that later when we get to multiplying polynomials and we do the box method. This will be your best friend. But I was trying to kind of associate it with multiplying 2-digit numbers. If you're too confused on that, don't worry. Remember, you should have SAT, ACT. You should have a calculator no matter what. I'm trying to show you all of the foundations, though, of where all this stuff comes from. So if I confused you a little bit right there, my apologies to you. Don't beat yourself up if it didn't make sense. Use a calculator. 56 times 0.35 and get that. Now, this isn't done, though. Because what are we doing? We're finding 35% off a $56 item. So we have to take that 56 and we're going to subtract $19.60 from it. Now, there's nothing over here. It's $56. So this is where borrowing takes place. And we make a 10. And if we needed to borrow here, we would turn that 10 into a 9 and make this a 10. This should hopefully be a review. If it's not, it's okay. That's why we're making these videos and kind of putting all the basic skills back into place. Want you to have a great foundation, because if you have that foundation of your building, of your mathematical building, the foundation, everything else will make sense a little bit quicker or make problems a little bit easier for you to understand. So that foundation is really key. Okay, so then we do 10 take away 6, and we're going to get 4. Decimals are still lined up, so we're just going to move that down. And we're adding and subtracting. We're not multiplying. When we multiply, that's when we have to count all the decimals. Adding and subtracting, just put them in line and take care of your business. Now, 5 take away 9 we cannot do, so we need to borrow again and make it 15. 15 take away 9 will leave us 6. And then 4 take away 1 will give us 3. So really, this item is now $36.40 after the 35% mark off. Okay. Now go ahead, take a second, pause the video if you need to. Try the next one. See how you do. See if you can get the answer before I just show it to you. Okay. I'm going to add a new color in here. Let's move some red. I haven't done any red yet. And we're going to change it to a decimal. Then we're going to do 242 times it by 0.25. And then you do your multiplication. It's going to be 10, 21, so that'll be 12. And then we'll put a placeholder. And then 2 times 2 is 4. 4 times 2 is 8. 2 times 2 is 4. Add them all up. And then once you are done adding them, so we should get 6050. Now, once we're done, count all of your numbers behind that decimal. There's only 2 of them. And now we're going to see that $60.50 is what we are going to take a discount off of the $242 item. So we are going to subtract $60.50. So we have to borrow again. So we're going to make this a 1, make this a 10, 0 take away 0, 10 take away 5, line the decimals up. They're big fat decimals right here. 1 take away 0 is going to be 1. 4 take away 6 we cannot do, so we have to borrow again and make this 14 take away 6, and that should be 8, and then carry the 1, or just bring the 1 straight down. You can put a 0 here for a placeholder. I don't think that's necessary, but you could if you wanted to. 1 take away nothing is still going to be 1. So now, after our discount, we should be paying $181.50 for that item that has a 25% discount. How are we feeling? Comfortable? Not comfortable? Where's your brain at? If you have questions, please find the teacher or come up to me, figure out what this is, because we definitely want you to be good at this. So find the total cost of $43.99 plus an 8.3% sales tax. So find the total cost. So really we're looking for the cost plus sales tax. And think about this. If the cost of the item, let's call it C. So we're going to take C plus C times times 0.083, because that's 8.3% converted to our decimal. And the sales tax, remember, when we did all these, we took the cost of our item and times it by the sales tax to find what our whole item was worth. Now, if we put a coefficient in front of C, couldn't we do a 1? Because isn't there a singular cost? So 1C plus 0.083C. Now we're doing something here, because now this is where the algebra comes into play. Oh crap, I forgot a 0. My bad. 0.83C. Okay, so think about this. Remember going back to our flour problems and combining like terms. Isn't a C, 1C, and a 0.083C the same thing? So really we can do 1.083C. So if we take the cost of this item and times it by our 1.083, we should actually get our final answer just doing one step. And this was $43.99. So I'm going to just use decimals for this one. So we're going to do 1.083 times by 40-something.99. 43.99. 43.99. And when we do that, we get 47.64. 47.64. And you can say, whoa, Schmidt, whoa, there was 0.64117. Correct. You are correct. But when we're dealing with money, really you want 2 decimal places. So if we only want 2 decimal places, we have to look at that third decimal place. And it was a 1. So we're going to put a 1 right here. And this is going to be our key number right there. If it is a 5 or higher, we can round it up. If it's a 4 or lower, including 0, then we keep it the same. We don't round down. We're just going to keep it the same for what it is. So it's either going to stay 0.64 or we're going to round it to 0.65. One of those situations is going to happen. But since our answer is 0.641, 1 is 4 or less than, so it's just going to keep it the same. And that's how we work on rounding too. Once again, that's another foundation that we're going to instill so that we don't have rounding errors. And in AP Calculus is a huge one. AP Chemistry is another one where significant figures are very important. If you haven't learned about sig figs, it's okay. You'll get there. But it's very important that you know how to round. I can't remember for the life of me. I think it's 3 decimal places for AP Calculus. Everything gets rounded to 3. But it's been 2 years since I taught it, so. But I think it's 3 places. And who knows, they might have changed by now. Find the total cost of a 180 item plus an 18% markup. So we're doing that same idea. If it were been a discount, so price plus sales tax, so we did the price plus sales tax or the price plus markup. So once again, we're doing we use the lingo that's here, price plus markup. So our price is 180 bucks. Our markup is going to take that 180 and times it by 0.18 because it's an 18% markup. So if we thought about it as P, the price, and our 18% markup price, we could get away with 1.18 P, and the price we already said was $180. So we could do this all in one fell swoop, or we could do it in one step just by taking our 180 and timesing it by 1.18. Now, we could, on the other hand, though, you could just do the markup, find the solution, and then add it to 180 like we did in the previous problems. But if you wanted to go the more straight route method, you could do it this way as well. So whatever you're convenient, whatever makes the most sense to you. Don't think about it as convenience. What makes the most sense to you, that's the one you want to focus on. Because if it makes sense, you will know why you are doing it later on when it comes to a test. And that's the most important part. So we did 1.18 times 180, and we got 212 and 40 cents. So 212 and then 40 and change. And that is our cost plus the markup, the 18% markup. So it'd be our 180 plus the markup. And if we just wanted to figure out what the markup was, we could subtract 180 from our 212.40, and whatever's left over, that's what it got marked up with. Because remember, we could take the original price off of it, and what we'll be left with is just the markup. Because it's price plus markup, so if we subtract the price, all we're left with is the markup. All right, last one. Finding total price. So we would take the price minus the discount or sale price. So now we're just reverting the idea as opposed to adding on the markups. Now we're just going to subtract them. So I am going to stop this there. I'm going to let you do this and see how well you can. Okay? I'm going to throw the solutions up. So you try it. I'm just going to work through it. So 32%, move it to 0.32. Then we're going to do a sale price. So we need the price minus 0.32 price. So here's where we get the 100% minus the 32% discount. So really we are only paying for 68% of what the actual item is. $6.50. And we'll do $96.50 times it by point. Was it 6.8? And get 65, 62. 62. Is that what you got? Hopefully I didn't screw it up too bad. 60% moves it to 0.6. We have one price minus 0.6 price, which would leave us with only 0.4 price. So 0.4 times 88. It's definitely going to be below 44 because if we cut it in half, that would be 50%. So that would be 44. So make sure your answer makes sense. So even before I do this, it better be lower than 44, which it is, 35.20. So $35.20 would be our final cost. And there we have it. There's our percentages. Once again, if you have questions, go to your teacher, come to me, whatever you need for the help room. If I haven't talked about this yet, you could also join the Discord chat. Links are in TikTok, in the classroom, wherever you need. Join this, ask questions on the general chat, or where it says questions, go to the questions tab, throw questions here. I get a lot of them in my private sessions. I want some more in the public sessions. So post your homework questions. I will help you. I will show though, if you go to general, I have had people post questions here. And then I make a video and tag them on TikTok. All right. Stop.